So we're going to look at the number e. The number e is a natural number. We call it the natural number e. It's a base for an exponential function, and it is convenient to use when for different applications involving calculus. So at the end of the last video, we talked about the compounding periods, and they're eventually, no matter how many times you compound, you're going to end up close to the same amount eventually. And so what I want to show you is if you would take this expression and as n gets larger and larger, it approaches this number. It's kind of like in calculus, we say it approaches a limit. So the larger the values I put in here for n, you're going to see it approach a limit. So I could create a table and see what happens. Let me grab the calculator and I can show you. So here's the calculator. And we're going to put this expression in for y. And instead of n, I'm going to use x because that's the variable in the calculator. So 1 plus 1 over n raised to the n power. And then I'm going to hit second table. And so I'm going to see that the value starts to get larger and larger. But the larger it gets, now I think what I'm going to do is actually change my table a little bit. So let's start the table at 1. But let's put my change in table at 500. This is by hitting the window button, I can change what the table looks like. So it's going to jump by 500. So it starts at 2, but then notice, look at these numbers are almost all the same, right? I didn't see that at the beginning with, 5, 10, 15. But as I get to like 100, 500, I get to this, the same number. And so that is, it approaches a limit, we say. And that limit that it approaches, this expression, is the natural number e. And so, and I have it rounded here to 5 decimal places, but you can see this is like it's an irrational number. We don't have an exact value. Similar to like pi, right? Continues on forever. If you hit second e, there's 2 places on the calculator. This one automatically puts in a spot for the exponent. So I'm going to just put in 1. So you can see that the calculator is going to end it here because that's how many it displays. And you also have second division sign. This one does not have the caret symbol. So this one comes in handy if you're going to be using a value for the exponent. So this is how you would get the natural number e on the calculator. So this right here is called the natural exponential function. So we talked about exponential functions. This one has a base of e. Remember the hardest thing to keep in mind is when you see a letter, you want to think, oh, that's another variable, but e is not a variable, it's a number. So this is a number. And it's at 2.71828, so on. So it's abbreviated with the letter e. So if we were to graph that, it would look like this. Let's hit graph. So it's an exponential function. It remember e is a base between 2 and 3, so it looks very similar to what we've seen when we use the base of 2 and the base of 3. So when you need to evaluate, say it said to find e to the 5th power, you would put in your calculator e and you would hit this to the 5th. If you do hit this other e here, you just hit the caret symbol after it, and then it gives you the value for that. And then you round it to whatever decimal place you need. So there's a lot of applications. You're going to see very many applications with this natural number. One of them, we started talking about compound interest in the last video. You also will see something called continuously compounding interest. And I kind of showed you that when we were doing the compound interest, you saw that after, if you compounded quarterly, if you compounded monthly, you got more. If you compounded daily, you got more, slightly more. So you could compound hourly, every second. And what you're going to see is that it will approach a limit where it won't, you start earning, it's going to be pennies, and then it will be less than pennies. So that will change. And so it approaches this limit, and that's the natural number e. And so instead of using the compound interest formula, when it tells you that the interest is compounded continuously, you can use this formula. I call it PERT. And so what are the parts of this formula? So this, as in the prior one, this is the future amount. The P, just like in the prior one that we talked about, is the principal. The R is the interest rate. Again, you're going to use it. This is the interest rate per year. You're going to use it in decimal form. And the T is the time in years. So the number of years that have passed. So let's take a look at an example. So here's our example we're going to look at. A sum of 10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years subject to continuous compounding. So this is very similar to the problem if you watched the previous video that I did the compound interest on. What's the difference here? Well, the big difference here is that you have this word continuous compounding, the phrase continuous compounding. So when I see the phrase continuous compounding, that's when I know to use this formula versus the prior formula. So it says continuous compounding, and that tells me use that. And so let's write down my variables. Now this time I only have 4 variables. Remember, the E is a number, it's a natural number. And the future amount is what I'm looking for. Find the balance in the account after 5 years. We have the annual rate, same as before. We have the principal of 10,000. So you want to go through the problem and highlight those information. So this is P, this is my R. Find the balance is my future amount, and 5 years is my time. Continuous compounding means I use this formula. So now let's plug in my numbers. And I'm going to put it in the calculator again in one step. I want to caution you, the biggest mistake I see here is putting into the calculator multiplying this first and then raising that to this exponent. Remember, if you're going to do it in 2 steps, you have to follow the order of operations. Order of operations says you cannot multiply this 10,000 by the e first. You have to do the exponent. So you have to do the exponent. You have to take e raised to this power first. Then you would multiply it by the 10,000. So if you are going to do it in 2 parts, make sure you remember the order of operations. Otherwise, just let the calculator do that order of operations for you. And we'll say 10,000. And then second, and I'll choose this e here to the left of 4 because I want the caret symbol. And again, if you have the caret symbol, you want to make sure that you're putting in the parentheses. If you have the superscript, that's not necessary. And I end up with this number. Now notice how when I did this last time, and remember I changed it from quarterly to monthly to daily. When I ended up with daily, I ended up with $14,917.59. So less than $1 for doing it every continuously, right? Less than $1 difference because it approaches a limit. And so I'm going to round this. So this is what my calculator screen displays. But I want to round to the 100th place or the nearest cent. And so I will look 1 to the right of that 100th place. And because that one is 6, which is more than 5, I'm going to round the 4 up to a 5. And so my answer is this $14,918.25. So this is an example of our continuous compounding and an example of how to use the natural number e in a problem application.